Okay, welcome back. We're going to be working on Intermediate Algebra, 4th edition, Martin Gay, and we're going to be doing section 2.5. We're going to do the even numbers up to number 50. Okay, now, this is going to be set theory, talking about sets. And first we're going to say set A is going to be x such that x is an even integer. Okay, and that's just a fancy way. B is going to be equal to odd, and I'm not going to rewrite that just because to save some time. And C is a specific set of the numbers 2, 3, 4, and 5. And D is going to be the specific set of integers 4, 5, 6, and 7. Okay, those are 4 sets. And now, problem 2 is going to be C intersect with D. That's a symbol for the intersection. It's the upside down U. Okay? U is for union, and the upside down U is for the intersection. So we can see that the intersection of C and D is going to be the numbers 4 and 5 because they're common to both sets. And that's the definition of a union. Of an intersection. So the answer would be the set 4 and 5. Okay? The next one is the union of set A and set D. Okay, A is the even integers, and D is 4, 5, 6, and 7. The only even integers are 4 and 6 in the set D. So, I'm sorry, the union. My mistake. I was thinking intersection before. So as far as the union, it's going to be all the even integers plus 5 and 7. So it's going to be even and 5 and 7. Okay? Sorry about that. I wasn't thinking. Okay? The next one is A intersect B. Now A is the even integers and B are the odd integers. Now the question is, what is the intersection? What is those elements that are in common to both of these sets? And the answer is, it's going to be the empty set. The empty set is always drawn as a 0 with a line through it. That's the empty set because there are no elements that can be in both of those sets. Okay, the fourth one, number 8, is B union of D. In other words, it's going to be the odds plus odd and those elements that are in D. And that's going to be equal to the odds plus 4 and 6. Which are the only even integers in set D. Okay, number 10 is B intersects C. B intersects C, that's going to be the odd intersected with set C. That'll be all of the odd elements of set C, which is 3 and 5. Okay, and then the last one is A union C. A are the even integers. So the union is going to be the even integers. And then you're going to union that with C, so you're going to add in these two odd integers, 3 and 5. Okay? And I kind of assumed that people know what a union is and what is an intersection. Okay? That completes that particular part of it. Now we're going to go to another part of it where they want us to draw 3 number lines. So I'll draw them here. 0, 0, 0, 1, 2, 3, 4. Okay, this would be 5, 5, 5, negative 5, negative 5, and negative 5. And you can kind of imagine what all the other ticks are. We're going to graph the two inequalities on the first two number lines, and we're going to graph the solution set on the third number line, and then we're going to write the solution in an interval notation. Okay, and the first one is going to be x less than or equal to 0 and x greater than or equal to negative 2. So on the first one, we're going to do x less than or equal to 0, so that's going to be this one. On the second one, I'm going to do x greater than or equal to negative 2. That's going to be this one. Then we're going to, the anding of those is going to be the intersection. So that's going to start at negative 2, and it's going to go to 0. Okay? If we write that in interval notation, it'll be negative 2, comma, 0. Okay? That was number 14. See if I can get that. Okay. Now number 18. I'm sorry, 16. That was 14. 16 is x less than 2 and x greater than 4. Okay, x less than 2, that's going to be this open interval here. Greater than 4, that'll be this open interval here now. That's an open interval. Now, what's common on these two is nothing. There's no, when you intersect those, the word and is synonymous with intersection. And there's no elements in common, so it's going to be the empty set. That's number 16. I guess I gotta figure out a way to erase that. Okay. Now, we get on to number 18. X greater than or equal to negative 4 and x greater than 1. Greater than or equal to negative 4. So we go to negative 4, greater than or equal to. Next one, x greater than 1. Okay, now they want to know what's the intersection of these. Well, what it's going to be is, it's going to be something that's going to include negative 4, but it's going to come all the way up here, and it's going to, it can't include positive 1 because positive 1 is not a member of this set. Well, it will include everything up to that. And writing that in set notation, in interval notation, is going to be negative 4 with a square bracket, excuse me. And then the 1 is going to be in the curved bracket. Okay, that's number 18. Now, number 20, write the solutions in interval notations. Let's see what how that comes out here. X plus 2 greater than or equal to 3 and 5x minus 1 greater than or equal to 9. So what we want to do on these is to isolate them for x. So this is going to be x greater than or equal to, 2 goes to the other side as negative 2. 3 minus 2 is 1. Now this side, we're going to move that to here, and that's going to go in as a positive 1. That's going to make 10 on the other side. Then we have to divide by the 5, so 10 divided by 5 is 2. So this one is going to say x is greater than or equal to 2. So x is greater than or equal to 1, and x is greater than or equal to 2. So let's start off here by actually using our number lines. X greater than or equal to 1 is going to look like this. X greater than or equal to 2 is going to look like this. So the combination of these is going to be all of the numbers between 1 and 2, including the 2 endpoints. And the interval notation for that is going to be 1, 2. Okay, I drew that one out so we could see it. After we get good at it, we might be able to just write it down by looking at these and thinking about this. Okay, that's number 20. Now, number 22. 2x plus 4 greater than 0. 4x greater than 0. So this is going to be 2x greater than negative 4, or x greater than negative 2, x greater than 0. X is going to be greater than negative 2, and x is greater than 0. But remember now, this is all and. So x greater than negative 2 looks like this, and x greater than 0 looks like this. So what you're going to do is you're going to go from negative 2 to 0, and it's going to be an open interval. Open interval means it does not include the endpoints. Closed interval means that it includes the endpoints. The open interval has the parentheses, or the round bracket, and the closed interval has the square bracket. So the answer on this is going to be negative 2, 0. Okay, let's go to number 24. 24 says negative 7x less than or equal to negative 21. So here we're getting into the negative one numbers. They use those to try to confuse you. X minus 20 less than or equal to negative 15. Okay, so we're going to bring the negative 7 over to the other side where it goes onto the bottom. Now I'll start erasing. Now when I do that, because I brought a negative sign over, I have to change that. Now the right-hand side is just a 3. So x is greater than or equal to 3, because two negatives cancel each other. Or you might say they annihilate each other. A negative and a negative make a positive. Okay, and now on the other side, we're going to move the 20 over. That's going to be plus 20, so this is going to be x less than or equal to 5. 20 minus 15. So x is greater than or equal to 3, but less than or equal to 5. So that's going to be a closed interval. It's going to start at 3, and it's going to finish up at 5. So we started off doing the diagrams, but now we're going to look at them, and we're going to try writing it without drawing the diagram. Okay? We're going to push ourselves a little bit. And if we make a mistake, that's okay, because the idea is to try to build up our capacity to do more of this without writing it all down. Okay, now solve each compound inequality. Okay, so let's see. The next one is going to be negative 2x, negative 2 less than or equal to x plus 3 less than or equal to 0. This is a compound inequality. This is actually two inequalities. So there's an inequality that negative 2 is less than x plus 3. Then there's another inequality that says x plus 3 is less than or equal to 0. We can solve these totally independent of each other. So on this one, we want the x to go on the one side, the negative 2 to go on the other side. So we're going to have negative x less than or equal to 3 plus 2, or 5. And then x is going to be greater than or equal to negative 5. Because we're going to get the negative sign over to the other side. Now on this hand, on the other hand, x is going to be less than or equal to negative 3, because we're going to bring it over. So, you can see up here on the number line, x is going to be greater than negative 5, but less than negative 3. So it's going to be a closed bracket, less than or equal to, greater than or equal to negative 5, and less than or equal to negative 3. So it's going to be a closed bracket, or that is a closed interval with a square bracket, and it's going to go between negative 5 and 3. Okay, that was number 26. Okay. Now number 28. 1 is less than 4 plus 2x less than 7. And I'm going to write this as 2 again, because I think that's the easiest way to do this. I really haven't done problems like this before. I don't think you can do these without making it 2 separate inequalities to start off. Okay, we want to get the 2x to the other side. It becomes negative 2x less than 3. X greater than negative 3 halves. Because I took the negative 2 and put it down. Switch the sign. This one, 2x less than 7 over 4. X less than 7 over 8. Okay, so x is going to be greater than negative 3 halves, but less than 7/8. So that's going to be an open interval. Going to start at negative 3 halves. It's going to finish at 7/8. Put the smaller one on the left and the larger one on the right. Okay? Okay, that's number 28. Now let's do number 30. This one says negative 2 less than 1/2 x minus 5, which is less than 1. It's a practical matter. These sorts of problems don't actually come up in engineering work. But that's okay, it doesn't matter. We can still perfectly legitimate puzzles. Negative 2 less than 1/2 x minus 5 and 1/2 x minus 5 is less than 1. So we're going to move this to the other side. So it'll be negative 1/2 x less than, we'll get the positive 2 on the other side, so we'll end up with negative 3. Then we're going to multiply both sides by negative 2. We're going to get x now, it's going to be greater than, and it's going to be 2. I'm going to turn that over to make 2 over 1 when you bring it onto the other side, and it's going to be 6. Okay, and over here, we're just going to bring the 5 to the other side. 1/2 x less than or equal to 6. X less than 3. I'm sorry, 12. At first I was dividing by 2, but I realized no, that 2 is going to end up on the top on the other side. It's going to be 12. X is going to be greater than 6, but less than 12. So that's going to be an open interval between 6 and 12. Okay. Okay. Now, number 32, negative 4 less than or equal to negative 2x plus 5 over 3, and that's going to be less than or equal to 1. So, once again, I'm going to make this into 2 separate inequalities and just do them individually. I could have first multiplied the whole thing by the 3, but I'm going to do that in 2 separate steps. I just think it makes it a little clearer. Okay, so I'm going to multiply through by the 3. I get negative 12 less than or equal to negative 2x plus 5. I'm going to move the 2x to this side. I'm going to move the 12 to the other side, where it's going to add to the 5 to make 17. And then the x is going to be less than or equal to 17 over 2. That's 8.5. Okay, now over here, we're going to multiply through by 3 to get negative 2x plus 5 less than or equal to 3. Okay, you're going to move the 5 to the other side, where it's going to be a negative 5, so we're going to end up with a negative 2. Going to divide both sides by a negative 2. That's going to reverse the sign of this. And the 2 is going to cancel on both sides. X is greater than or equal to negative 1. I'm sorry, x is greater than or equal to 1. So it's going to be greater than or equal to 1, but less than 8.5. So that's going to be a closed interval, starting at 1 and going up to 17 halves. I'm just going to leave that at 17 halves. Okay. Now, we're on to 34. 34 says we're going to use the 3 number lines again, so I'm glad I left those up there. It comes in handy. It says in this case we have x less than 0 or x less than 1. Okay, so here we're going to be using or instead of and. And this is going to correspond to a union instead of an intersection. Okay, so first we have x less than 0. That's going to be the open interval that goes this way. Or x less than 1. X less than 1 is going to be the open interval that goes this way. And we're going to now take the union of these, because any element which is in either this or that is going to be the union. And that's just going to be this lower one, because the lower one actually, the upper one is a subset of the lower one. So every element that's in here is already in there. Plus this has some extra ones. So the answer is going to be this open interval that goes from negative infinity up until 1. Okay? Okay. And I don't think it matters. I think we've gone into this before, about whether if it's got an infinity on it, would it possibly matter if you wrote it as an open interval or a closed interval? Because infinity is not a specific point anyway, so we're just going to use the open interval. I think that's what they do in the book. It's not an important distinction. That's number 34. So let's go to number 36. Okay. X greater than or equal to negative 3 or x less than or equal to negative 4. Okay, negative 3 greater than or equal to, that goes this way. The other one is going to be negative 4, which is here. It's going to go this way. Okay, these don't overlap, but we're going to be taking a union, so we're going to get both of them. So the final answer, which I can draw on the bottom one, I should have drawn that on the other ones. I forgot. I wasn't drawing the answer on the bottom plot. But this one is going to be this set. This set is actually 2 intervals. It's not a single interval. If I had to write this as interval notation, I would say that it's going to be the interval negative infinity to negative 4, closed. And then I'm going to have to say I'm wondering what the correct syntax is for more than one interval. I guess I'm going to use the union sign. That seems to be what they do. In other words, I could have written the word and, but I'm going to use the union sign rather than to write the word and. And that's going to be closed interval starting at negative 3, and then it's going to go to infinity. But I could have also written, instead of that, I could have written and, but I noticed in the book it has the union sign. Okay? It's not a single interval, it's 2 intervals. You have to have some way of attaching them, and we're going to use the union sign there for that. Okay. Okay. Now, just a number 38. X greater than or equal to -2 or x less than or equal to 2. So greater than or equal to -2, that's this one. Less than or equal to 2, that's this one. So you can see that what you're going to end up with is it's going to go from -2 to +2. And I'm sorry, I should have put the zeros all below the line here. It would have made it easier to draw them. And interval notation, that's going to be -2, +2. Okay, that's number 38. That brings us up to number 40. Okay, number 40. Number 40 says, solve each compound inequality and write the answers in the interval notation. First one is -5x less than or equal to 10, or 3x minus 5 greater than or equal to 1. So we're going to, once again, we have to solve each of these individually. Okay? So this is going to be x greater than or equal to 2. Because I have to divide both sides by the -5, that's going to turn the less than into a greater than sign. And the 10 divided by the 5 is going to be 2. And I forgot to leave the negative sign on there because it's 10 divided by -2. So x is greater than or equal to -2. And on this side, it's going to be 3x greater than or equal to 6. Because I have to bring that over to the other side. And that's going to be x greater than or equal to 2. So what we're going to have is x is going to be greater than or equal to -2, or x is greater than or equal to 2. So it's going to be the union of this and this. And the union of those two is just going to be this. And it's going to be actually just this first interval, x, and it's going to be the interval -2 to infinity. Okay, that was number 40. Okay, now we do 42. Okay, 42. X plus 9 less than 0, or 4x greater than -12. Okay, this is going to be x less than -9, because I move over the 9, and this is going to be x greater than -3, because I divide by the 4. So x less than -9, well, that's going to be over here. It's going to be an open interval that starts at -9. And then x greater than -3, that's going to be an open interval that's starting at -3. And then it's or, so we're going to have a union of two sets. So it's just going to be the two of these together on this lower one, so I'm not going to draw them. And in the interval notation, it's going to be negative infinity up to -9 with an open interval, and then it's going to be a union of that with -3, the interval of -3 to infinity. That's number 42. Okay, so that brings us to 44. 5x minus 1 greater than or equal to -5, or 5 minus x less than or equal to 11. Okay, that 5, we're going to get x minus 1 greater than or equal to -1 by bringing that -5 over down under here. Then we're going to have x greater than or equal to a -1 plus, this one becomes a +1, x greater than or equal to 0. And on the side over here, we're going to have -x less than or equal to, we're going to subtract the 5 from both sides, and we're going to get 6. And then that's going to be x, it's going to be greater than or equal to -6. And when you bring over the -1, we have to flip that. So x is going to be greater than 0, or greater than -6. But you can see here that that's going to just be x is greater than -6, because -6 is going to go from here to the right, 0 goes from here to the right. So the final answer is going to be a closed interval. It's going to start at -6. It's going to go all the way to infinity. Okay, and that's number 44. Okay, we did that without drawing it. Okay, that brings us to 46. Solve each compound interval inequality and to write the solutions in an interval notation. So we have x less than 5/7 and x less than 1. Okay. Well, let's just have a look at that. 5/7 is a number which is between 0 and 1, so I'm just going to approximate it as a number in between, and it's less than that. And the second one says x is less than 1. Okay? And it says and. And means an intersection. So when we intersect these, we're going to get something that actually intersects. It has to be in both sets. It has to be in both sets. It's just going to be in the upper one. It's just going to be the open interval from -infinity to 5/7, because that is contained within this one. Okay, we did that one using the drawing. Okay, that was 46. Now 48 is, that's funny. Oh, okay, x less than 5/7 or x less than 1. It's almost the same as the other one, only the only difference is it's got the or, so let's see how that works out. X less than 5/7, so that's an open interval, or x less than 1. Now, x less than 1 is the same there, but now we're going to take the union of these, so we're going to actually get the bigger one here, because we're going to get those elements that are in both. So that's just going to be -infinity up into 1. Okay, it's actually going to be the lower one. And we only have one more problem left. That's number 50. Okay, and that says 3 less than 5x plus 1 less than 11. Okay, so let's do this as two separate ones. I think that's really the best way to do it. Okay, we're going to move the 5 over, and we're going to move the 3 over. We've got -5x less than -2. That's 1 minus 3. Then we're going to get x, instead of less than, it's going to be greater than. It's going to be -2 divided by -5. That's just 2/5. And on this one over here, it's going to be 5x less than 10. That's what happens when we bring that over, and that's x less than 2. Okay? So now, what I didn't write in here, see, this is has to be and, because these two inequalities have both to be satisfied at the same time, so they both have to be true. So this is going to correspond to the intersection. Intersection rule would apply here. Okay, so let's just draw them out. X greater than 2/5. 2/5 is somewhere between 0 and 1. X is greater than, it's going to be an open interval. It's going to go like this. X less than or equal to 2 is going to be an open interval going this way. And for this inequality to be satisfied, both of these have to be true. So we're actually going to get that open interval, which extends from one to the other. And that's going to be an open interval. It's going to start at 2/5, and it's going to end at 2. Okay, that's number 50. That finishes today's assignment. And please leave me any notes if you have any questions on any of these. Okay, good night.